The question says a student tied a small stopper to the end of a string of length 1 meter and welded in a vertical circle. Question number A. What is the minimum speed that it must have at the highest point so that the string does not slacken? B. What is its speed at the lowest point if it has the above minimum speed at the highest point? This is the question that we are going to consider. It is a scenario where a stopper is tied, or a small thing, any small object is tied to the end of a rope. Then you try to weld it in a circular path. Then what is the minimum velocity at the highest point? What is the minimum speed at the highest point? And what will be the velocity at this lowest end? We can begin by saying force is equal to ma. So this one we're going to have summation of forces is equal to ma. So here we have the tension here, tension 2, then we have this one is coming in this direction. Then as it is, as a stone or as a stopper is being welded in a circle, here the tension will be acting in this other direction so as to support the motion or the movement, so that it does not go away. Then the mg here, they are in the same direction. Mg must be equal to ma. So we have m, and since it's a circular path, this one acceleration is centripetal acceleration, which is given by v squared over r. So this is the equation. We can also find that this one T1 minus mg must also be equal to the same, but this is sufficient to work with. So this one, in order for the speed to have the minimum speed here at the top, then the tension here, the tension in the rope must be equal to 0 for a minimum velocity here. So we can, where there is T2, we're going to put a 0 plus mg, which is equal to mv squared over r. So here we have mg is equal to mv squared over r. Since we want, so this is of course this is 2, and this is also b2. So here we can divide, or we can multiply both sides by r over m, so that we have mg times r over m is equal to mv squared over r times r over m. This and this will go, this and this will go, then this and this will go. So here we're going to have gr is equal to v squared. This is the same as v squared is equal to gr, which when we plug in the values for g with 9.8 times this one, radius is simply 1. So our v is equal to square root of 9.8, which will give us 3.13 meters per second. So this is the minimum velocity at the top. The minimum velocity at the top. So v min at B, which is the highest point, is equal to 3.13 meters per second. So from this, we can go on. Let me just erase this. In order for us to find the velocity here at this point, we can use the principle of energy conservation, which states that energy can neither be destroyed nor created. but can only be converted from one form to another. So for part B, this is B. For part B, we are going to use the energy conservation principle. So here, we have the energy here, since we want to find the velocity here, and the energy that is possessed by a moving object is kinetic energy. So we have the kinetic energy at A. That must be equal to, so here, must be equal to the total energy that is here. But here we have both the potential energy and kinetic energy. So here we have this one due to position, and as it moves again, there is also some kinetic energy. So it's equal to Ke at B plus EE at B. So this one we can plug in now. Okay, we can write the formula. mv1 squared is equal to, so this one, so we have m half m v2 squared plus mgh. So from this point, we know that for height, this is the radius, and from this point to this point, it is radius. So this is r, and also this r. And from this point to this point, it is going to be 2r. It is r plus r. So h is equal to 2r. So from this, we can see that there are certain things that are able to cancel. Let us do this so that we multiply by 2 and divide by m, so that we cancel this, and this. Then here we are going to have v1 half times 2. Here we are just going to have v1 squared is equal to, so this and this will also cancel, and this one. Then here we are going to have a2 that will come here. So we have v2 squared plus 2gh. And since h is equal to 2r, we have v1 squared, v2 squared plus 2g times 2r. And this one, we can go on. v1 squared is equal to v2 squared plus 4gr. But v squared, v2 squared is equal to gr. That's what we found when we were dividing for a, when we are finding, or when we are working out with a. So this one is equal to this one. So if we put this one in this one, we're going to have v1 squared is equal to v2 squared plus 4gr. So here we put gr plus 4gr. So what we're going to get is 5gr as v1 squared. So introducing the square root to both sides, we're going to have v1 is equal to square root of 5gr. Putting in the values, we are going to have square root of 5 times 9.8 times 1, which will give us 7 meters per second as the speed. If the speed here at the highest point is minimum, even here at the lowest point, it is going to be the minimum velocity. So this is how this question must be answered. Thank you so much for watching the video.